Hello there and welcome. I am so glad you are here tonight. Maybe it was a long day, full of noise and hurry and things to remember. Or maybe you are just someone who finds peace in thinking about quiet and distant things. Either way, this journey is for you. You can let your thoughts soften now and let your body rest. If you enjoy these quiet journeys, consider liking and subscribing. It helps others find us. Tonight, we will drift gently through our solar system. We begin in the deep, cold darkness, far from the sun. Out here, there is a planet, painted a soft, dreamy blue. This is Neptune. It is so far away that the sun is just a bright star in its sky. The cold here is deep, a forever kind of cold that freezes almost everything. You would think a place so cold and so far from the sun's warmth would be still. Perfectly, absolutely still. But it is not. Neptune is a world of wind. Not a gentle breeze like we know on Earth. These are the fastest winds in the entire solar system. They move faster than the speed of sound. Imagine a sound so loud and so powerful, it breaks a barrier in the air. That is how fast the winds of Neptune travel. They rush through the planet's upper atmosphere at more than 2,000 kilometers per hour. That is many, many times faster than the strongest hurricanes on Earth. It is a silent storm, however, because in space there is no air to carry the sound. So these winds blow in total silence. What powers such incredible speed in such a cold place? It is the planet's own warmth. Deep inside, Neptune has a warm core, left over from when it was formed billions of years ago. This gentle heat rises up, and it stirs the frozen atmosphere. It is like a pot of water, gently simmering on a very low flame. The atmosphere itself is made of simple things: hydrogen and helium, the lightest gases in the universe, and methane, which is what gives the planet its beautiful blue color. The methane ice crystals are whipped into great, white clouds. These clouds look like long, thin streaks pulled across the blue surface. For years at a time, giant storms can appear. Dark spots, the size of entire continents on Earth, swirling in the cold. But unlike Earth's storms, which are driven by the sun's heat, these are born from the planet's own inner warmth. A frozen world, wrapped in winds that break the sound barrier in perfect silence. Now, we drift inward, closer to the sun. We come to a world that is quiet and red and still. This is Mars, the red planet. Its surface is covered in fine, red dust, like a desert that never ends. There are no oceans, no rivers, no noise. Just a quiet, chilly stillness. But on the surface of this quiet world is a scar. A canyon so enormous it makes our own Grand Canyon look like a tiny scratch. It is called Valles Marineris, the Mariner Valley. It stretches across the middle of Mars, like a great, long crack. If you could place it on Earth, it would reach all the way across the United States, from one coast to the other. That is how long it is, and it is deep. In some places, the canyon floor is 7 kilometers below the land around it. That is more than 5 times deeper than the Grand Canyon. If you were to stand on the edge, you might not even be able to see the bottom. It would be lost in haze and shadow. The silence here would be total. A deep, unbroken quiet that has lasted for ages. This giant canyon was not carved by a river like the canyons on Earth. There was not enough water flowing for long enough to cut through so much rock. Instead, scientists believe the canyon is a crack in the planet's skin. A very, very long time ago, Mars was more geologically active. Nearby, a region of giant volcanoes began to bulge upwards, pushing the crust higher and higher. This tremendous pressure caused the crust of Mars to stretch and stretch until it finally tore open. The ground itself pulled apart, creating this vast system of canyons. So Valles Marineris is a wound, a memory of a time when the planet was shaking itself apart. Now it is all quiet. The volcanoes are silent. The stretching has stopped. All that is left is this immense canyon, a quiet reminder of a loud past, frozen in time. We continue our journey, moving even closer to the sun's warmth. And we arrive at a planet that looks soft and gentle from a distance, a world covered in thick, white clouds. This is Venus. It is often called Earth's twin. It is almost the same size as our world. It is made of the same kind of rock and metal. But it is not like Earth at all. It is a furnace. The surface is hotter than an oven, hot enough to melt lead. And there is something missing here. Something very important that our world has. Venus has no magnetic field. On Earth, deep in our planet's core, liquid iron is swirling and flowing. This motion creates a powerful, invisible shield around our planet, a magnetic field. This shield protects us. It pushes away the harmful radiation and the solar wind that streams constantly from the sun. It is like an invisible umbrella, keeping us safe and dry from a cosmic storm. Venus does not have one. Its core might be sluggish, or maybe even solid. Without the flow of molten metal, the magnetic shield was never born, and so, for billions of years, the solar wind has hit Venus with its full force. It has stripped away the lighter parts of its atmosphere, carrying them off into space. This might be why Venus, which could have once been a gentle world like Earth, became so harsh. Without that invisible shield, it was left exposed. The sun's energy, which gives us life, slowly turned Venus into a baking, lifeless desert. It is a quiet reminder of how a small difference, deep inside a planet's heart, can change everything about its surface. Now, we drift away again, back into the cooler, dimmer parts of the solar system. We come to two more giant planets that look like soft, glowing jewels in the darkness. Uranus, a pale, ghostly blue, and Neptune, the deep, rich blue we have seen before. These are the ice giants. They are made of water and methane and ammonia, all frozen into a slushy, deep atmosphere. Far below the clouds we can see, deep inside these planets, the conditions are almost unimaginable. The pressure is immense, millions of times greater than the pressure we feel on Earth, and the temperature is incredibly hot, thousands of degrees. In this strange, crushing environment, something magical might be happening. Scientists believe it might rain diamonds. The methane gas, which is made of carbon and hydrogen, gets broken apart by the intense heat and pressure. The carbon atoms are squeezed together so tightly that they crystallize. They turn into tiny, hard diamonds. These diamonds, heavier than the slushy atmosphere around them, would then slowly fall. A gentle, glittering rain drifting down through the deep, dark blue. A storm of diamonds, sinking for thousands of miles, towards the planet's core. This is not just a guess. Scientists have recreated these conditions in laboratories on Earth. They have taken the same kinds of materials and squeezed them with incredible pressure and watched as tiny diamonds formed. So, while we cannot see it, it is possible that deep within the blue clouds, of the most distant planets, a quiet, endless shower of crystals, is always falling. Now we return to our own neighborhood in space, back to our home, Earth. From space it looks so alive. Blue oceans, swirling white clouds, and green and brown continents. But one of the most important things about our planet is something you can't see at all. Earth is the only planet we know of that has plate tectonics. The surface of our world is not one solid piece. It is broken up into giant plates, like the pieces of a puzzle. These plates are always moving, very, very slowly. They float on top of the softer, hotter rock below. Where these plates crash into each other, mountains are pushed up. Where they pull apart, new oceans can form. This constant, slow movement is what causes earthquakes and volcanoes. It may sound destructive, but it is also what keeps our planet alive and stable. This recycling of the crust helps to regulate our climate over a very long time. It helps control the amount of carbon dioxide in the atmosphere, keeping the temperature just right for life. When we look at other rocky planets, like Mars or Venus, we see volcanoes and cracks in their surfaces. But their crusts seem to be stuck in place. They are geologically quiet compared to Earth. Our planet's moving plates are part of what makes it a living world. A slow, steady breath that shapes the continents and makes our home a comfortable place to be. Now we leave the planets behind for a moment and drift into the space between them. Here, in the dark emptiness, are millions of rocks. The asteroids. They are leftover pieces from when the solar system was first forming. We often think of them as lonely wanderers, drifting through space by themselves. But some of them are not alone. Some asteroids have their own tiny moons. Smaller rocks that orbit the larger ones. The first time we ever saw this was in 1993. A spacecraft called Galileo was flying past an asteroid named Ida. And as it looked at the pictures, scientists saw something amazing. A tiny little rock, just a mile across, was orbiting Ida. They named it Dactyl. Since then, we have found many more. Dozens of asteroids with their own small companions. Some even have 2 moons. And some systems are made of 2 asteroids of about the same size, orbiting each other like dance partners. These tiny moons were probably captured by the asteroid's gentle gravity. Or maybe they were broken off during a collision long ago. Even here, in the quiet, empty space between planets, gravity finds a way to bring things together, creating tiny, miniature solar systems of rock and dust, drifting silently in the dark. Let's travel back towards the Sun again, past Earth, past Venus, to the very closest planet to the Sun, Mercury. This is a world of extremes. During its long day, the surface gets incredibly hot enough to scorch rock. But during its equally long night, with no real atmosphere to hold the heat, it becomes freezing cold. Mercury does not have an atmosphere like Earth or Venus does. It doesn't have a thick blanket of air. Instead, it has something called an exosphere. It is so thin, it is almost a vacuum. The atoms in this exosphere are very far apart. They almost never bump into each other. They just bounce around like tiny balls on a huge, empty playground. This ghostly atmosphere is made of atoms that have been knocked off the planet's surface. The constant solar wind and tiny micrometeoroids are always hitting Mercury's rocks. And when they do, they blast atoms of sodium and potassium and oxygen up into the sky. But Mercury's gravity is very weak. It can't hold on to these atoms for long, so they are always escaping, drifting away into space, and new atoms are always being blasted up from the surface to replace them. So Mercury is surrounded by a very thin, always changing, shimmering cloud of atoms. It is completely invisible to our eyes. But with the right instruments, you can see it. A ghostly halo around a scorched and silent world. And at the very center of it all is the source of all this energy. The sun. It looks so calm and steady from far away. A perfect, glowing ball of light. But it is a place of incredible power. At its heart, in its core, it is a nuclear furnace. Every single second, the sun is changing. It is turning its own mass into pure energy. Over 4 million tons of its matter vanish every second. That is the weight of a huge mountain disappearing every single second. This happens through nuclear fusion. In the sun's core, the pressure is so great, and the temperature is so high, that hydrogen atoms are squeezed together. They are forced to combine to become helium. And when they do, a tiny bit of their mass is converted into a huge amount of energy. That energy is the sunlight that warms our planet. It is the light that grows our food. It is the energy that drives our weather. The sun is sacrificing a tiny piece of itself to give life to the whole solar system. Compared to the sun's total size, this loss is very small. The sun is so enormous, it holds more than 99% of all the mass in the entire solar system. All the planets and moons and asteroids put together are just a tiny fraction of what is left, so it has plenty of fuel to last for billions of years more. But still, it is a quiet, steady process. With every ray of sunlight that touches your face, a tiny part of the sun has turned into warmth and traveled all the way across space just to reach you. Now, we move out again to the planet with the most beautiful and famous feature in our solar system, Saturn. Its rings are like a dream, a wide, flat disk of shimmering light encircling the planet. They look solid and permanent and timeless. But they are not. Saturn's rings are slowly disappearing. They are falling into the planet. This process is called ring rain. The tiny particles that make up the rings, which are mostly made of water ice, are being pulled in by Saturn's gravity. And the planet's magnetic field is also helping to draw them down. Streams of these icy particles are constantly drifting from the rings down into Saturn's upper atmosphere. It is a very, very slow process. So slow you could never see it happen. But it is happening. Scientists who studied the data from the Cassini spacecraft think that the rings are quite young, maybe only 100 million years old. In the long life of the solar system, that is not very old at all. And they might disappear completely in another few 100 million years. So we are lucky. We live in a time when we can look up and see Saturn in its most beautiful state. A shining planet with shimmering temporary rings. A cosmic spectacle that will one day fade away. Let's return to the red planet Mars. We have already seen its giant canyon, but this quiet, desert world has another dramatic feature: dust storms. Not small, local storms. Mars experiences dust storms that can cover the entire planet. These storms can start small, with a little gust of wind lifting the fine, red dust into the thin air. But sometimes they grow and grow until the whole planet is wrapped in a hazy, red cloud. These giant storms can last for weeks or even months, They block out the sunlight, casting the surface in a dim, red twilight. The dust is so fine, it can stay floating in the atmosphere for a very long time. In 2018, one of these planet-covering storms was what ended the mission of the Opportunity rover. The little robot was powered by solar panels, and as the dust covered the sky, it could no longer get the sunlight it needed to charge its batteries. After the storm finally cleared, the rover never woke up. Its solar panels were likely coated in a thick layer of red dust. So even though there are no oceans to storm and no rain to fall, Mars is still a restless world. A quiet, dusty planet that sometimes disappears completely. Inside a soft, red storm, now we travel outward again past Mars and into the realm of the giant planets. Here, orbiting the great planet Jupiter, is a small moon that looks like a marbled, white and brown ball. This is Europa. Its surface is made of ice, a thick shell of frozen water that is crisscrossed with long, dark cracks. It is one of the smoothest surfaces in the solar system. There are very few craters. This suggests the ice is young and is always changing. But the most exciting thing about Europa is not on its surface, it is beneath it. Underneath that thick shell of ice, there is very strong evidence for a huge, salty ocean. An ocean of liquid water. How can a moon so far from the sun have an ocean that isn't frozen solid? The answer is Jupiter. Europa is constantly being pulled and squeezed by Jupiter's immense gravity, and also by the gravity of the other nearby moons. This constant flexing heats up the inside of Europa. It is like bending a paperclip back and forth. It gets warm. This internal heat is enough to keep the water beneath the ice in a liquid state. Scientists have seen hints of this ocean in many ways. The moon's magnetic field behaves like there is a layer of salty water moving around inside it, and the cracks on the surface look like places where the ice has broken and shifted as it floats on the water below. What is so fascinating is that this hidden ocean could possibly be a place for life. It is a dark, alien sea, warmed by the planet's pulling and sealed beneath miles of ice. But it has water and heat and likely the right chemical ingredients from the rock on the ocean floor. A quiet, hidden world with a secret ocean that might be one of the most promising places to look for life beyond Earth. Back on the quiet, red surface of Mars, there is another feature that dwarfs anything we have on Earth. A volcano. Its name is Olympus Mons, Mount Olympus. It is the tallest volcano in the entire solar system. It stands nearly 22 kilometers high. That is almost 3 times taller than Mount Everest. It is so wide, it would cover an area the size of the state of Arizona. If you were standing at its base, you would not even be able to see the top. The slope is so gentle and the volcano is so huge that the peak would be beyond the horizon. Olympus Mons grew so enormous, partly because Mars does not have plate tectonics. On Earth, the crust is always moving. A volcano might form over a hot spot, but then the plate moves, and the volcano is carried away from its source of magma. This creates chains of smaller volcanoes, like the Hawaiian Islands. But on Mars, the crust stays still, so a hot spot can pump out lava in the same place for millions and millions of years. Eruption after eruption after eruption, slowly building the volcano, higher and wider. The result is this single shield volcano of truly gigantic size. It looms in the thin Martian air, a silent monument to a time when the planet's heart was much hotter. Now, we return to Saturn and its beautiful rings. We know they are slowly disappearing, but there is something else about them that is hard to believe. They are incredibly thin. The rings stretch out for more than 280,000 kilometers from one side to the other. That is a vast distance. But in most places, the rings are less than 100 meters thick. That is thinner than a tall building. It is like a sheet of paper, the size of a city. The rings are made mostly of water ice. The particles range in size from tiny grains of dust to chunks as big as a house. Billions of these icy pieces are all orbiting Saturn together in a very flat plane. Their flatness is kept in place by Saturn's gravity and by the gentle influence of small moons that orbit within the rings. These are called shepherd moons because they help to keep the ring particles in their place. From far away, the rings look solid and smooth. But if you could fly through them, you would see they are a delicate, shimmering cloud of ice, so thin that if you look at them edge on, they almost disappear completely. Now let's think about our own planet again. Earth. We have talked about its moving plates and its magnetic field, but there is something else that makes it special. Of all the planets in our solar system, Earth is the densest. This means it has more stuff packed into a small space than any other planet. This is because of what it is made of. Earth has a very large, heavy core made of iron and nickel, and a thick mantle made of heavy, silicate rocks. Our planet's average density is about 5.5 grams per cubic centimeter. A gas giant like Jupiter is much, much larger than Earth. But it is made of very light gases, so its overall density is much lower. Earth's high density is very important. It is what gives us our strong gravity, and it is related to the molten, moving core that generates our protective magnetic field. Our planet is not just a collection of rock. It is a compact, heavy, and layered world, and this internal structure is what shapes so much of what happens on the surface. Let's return one last time to the Sun. That giant, glowing star at the center of everything. We can't hear it, of course. Space is silent, but the Sun is not quiet. It is constantly ringing like a giant musical instrument. The whole Sun is vibrating with sound waves. These are pressure waves that are created by the churning, boiling motion of the hot gas inside the Sun. These waves ripple through the Sun's layers, bouncing from one side to the other. They make the surface of the Sun gently rise and fall in a very complex rhythm. Scientists can study these vibrations using a special technique called helioseismology. It is just like how geologists on Earth use the waves from earthquakes to learn about what is deep inside our planet. By watching how these sound waves travel through the Sun, scientists can map its hidden interior. They can learn about its temperature and its density and how it rotates far below the surface we can see. These solar songs are at a very, very low frequency, far too low for our ears to ever hear. But the Sun is always humming, quietly revealing its deepest secrets through the gentle rhythm of its own vibrations. Now we visit Earth's troubled twin once more, Venus. We know it is incredibly hot. We know it has no magnetic field. But it has another very strange quality. It spins backward. Almost every other planet in the solar system spins in the same direction. But Venus rotates in the opposite direction. This is called retrograde rotation. If you could stand on the surface of Venus, you would see the sun rise in the west and set in the east, and its spin is also incredibly slow. A single day on Venus lasts for 243 Earth days. That is longer than its entire year. It takes Venus less time to go all the way around the sun than it does for it to spin just once on its axis. Scientists are not exactly sure why this happened. One idea is that very early in its history, Venus was hit by a huge object, a collision so powerful, it knocked the planet over and made it spin the other way. Another theory is that the thick, heavy atmosphere and the pull of the sun's gravity over billions of years slowly dragged its rotation to a stop and then reversed it. Whatever the reason, Venus is a world out of step with the rest of the solar system. A slow backward turning planet with a rhythm all its own. Now we go to the king of the planets, Jupiter, the largest, most massive planet in our solar system. It is a world of swirling clouds and giant storms. But it is not just a planet. It is the center of its own little solar system. Jupiter is the king of moons. As of right now, astronomers have found more than 90 moons orbiting the giant planet, and they are still finding more. The 4 biggest moons are famous: Io, Europa, Ganymede, and Callisto. They are so large. They were first seen by Galileo with his very first telescope over 400 years ago. They are called the Galilean moons. But beyond these 4 giants, there is a whole swarm of smaller moons. Many of them are probably captured asteroids that flew too close to Jupiter and were pulled into orbit by its powerful gravity. Some of these little moons orbit backwards. Some are only a few kilometers across. They are irregular and potato-shaped. Together, they all circle the great planet, bound by its immense gravity. A huge, diverse family of moons, telling a story of Jupiter's long and powerful history. Let's make a final visit to the small, scorched planet Mercury. We know it is a world of fire and ice, extremely hot in the sunlight and deeply cold in the dark. It seems like the last place you would expect to find water, but it is there. Mercury has ice. At its north and south poles, there are deep craters. The floors of these craters are in permanent shadow. Because Mercury's axis is not tilted very much, the sun's rays never, ever reach the bottom of these craters. They are some of the coldest places in the entire solar system, and in these natural, deep freezers, water ice has survived for millions of years. Spacecraft using radar have bounced signals off of Mercury's poles, and they found bright, reflective patches in exactly these shadowed places. Later, a spacecraft orbiting Mercury confirmed it. It is real water ice hiding in the dark. The water probably arrived on Mercury from comets. Comets are like giant, dirty snowballs, and when they crash into a planet, they deliver water. On most of Mercury, that water would instantly turn to steam and be lost to space. But if a comet hit near one of the poles, some of that water vapor could have drifted into one of these cold, dark craters. And once there, it would freeze and be trapped. So in the heart of the hottest planet, ice survives. Not under the sun, but hidden from it. Locked away in a perfect, cold darkness that has lasted for ages. Now we travel to the very edge of the solar system, to the most famous of the small, distant worlds, Pluto. For a long time, we knew very little about it. It was just a tiny, faint point of light in our most powerful telescopes. But in 2015, the New Horizons spacecraft flew past Pluto, and it sent back pictures that changed everything. We saw a world of incredible beauty and surprise, a world with mountains made of water ice and plains of frozen nitrogen. And on the surface of Pluto, there is a huge, bright feature shaped like a heart. This heart is called Sputnik Planitia, and it is not just a pretty shape. It may be a clue to a secret hidden deep inside Pluto. Many scientists believe that beneath this heart, there could be a vast, underground ocean. An ocean of liquid water, or something slushy like a half-frozen sea. Pluto is incredibly cold. Far too cold for liquid water to exist on the surface, but deep inside, there might be enough leftover heat from when it formed, and from the decay of radioactive elements in its rock, to keep a layer of water from freezing solid. The ice shell above it would act like a thick blanket, insulating the ocean and keeping it warm. The evidence comes from the weight of the heart itself, and from signs of recent geological activity on its surface. So even out here, in the frozen twilight, so far from the sun, a hidden ocean may quietly exist. A cold, dark sea on a tiny, distant world. Let us now travel through a part of the solar system that is often imagined, but rarely understood. The asteroid belt. It is a wide region of space between the orbits of Mars and Jupiter. In movies and stories, it is often shown as a crowded, dangerous place. A field of tumbling rocks that you would have to dodge and weave through. But in reality, the asteroid belt is mostly empty space. It is vast, and the asteroids are very, very far apart from each other. There are millions of them, it is true. But they are spread out over such a huge area that if you were flying a spacecraft through the belt, you would almost certainly never even see one. The chance of accidentally hitting one is almost zero. The total amount of material in the entire asteroid belt is actually very small. If you gathered up every single asteroid, from the biggest ones, down to the tiniest specks of dust, and put them all together, they would form an object that is less than 5% of the mass of our own moon. Most of that mass is in just a few of the very largest asteroids. The rest is just scattered, ancient debris. These are the building blocks of a planet that never was. Leftover pieces from the beginning of the solar system that were kept from coming together by the powerful gravity of nearby Jupiter. So the asteroid belt is not a crowded field of rocks. It is a quiet, empty place with a few lonely objects drifting millions of miles apart. In the silent darkness, now we visit a truly strange world, Uranus. The pale blue ice giant. Most planets spin like a top. They are tilted a little bit on their axis, but they basically spin upright as they go around the sun. Uranus is different. It is tipped all the way over on its side. Its axis is tilted by 98 degrees. So it does not spin, it rolls. It rolls along its orbit around the sun, like a ball rolling on a table. This extreme tilt gives it the most bizarre and extreme seasons in the solar system, because it is tipped over so far. One of its poles points almost directly at the sun for a part of its long orbit. This means that for that pole, it is daylight. For 42 Earth years straight, a summer that lasts for decades. And at the same time, the other pole is pointed away from the sun, plunged into a continuous 42-year-long night, a winter that lasts for a lifetime. Scientists are not sure why Uranus is tilted so much. The most likely idea is that a very long time ago, when the solar system was young and chaotic, Uranus was hit by another large, planet-sized object. The collision was so powerful, it literally knocked the planet over on its side, and it has been rolling that way ever since. A quiet, sideways world with seasons of light and darkness that last for an eternity. Let's return now to the giant of our solar system, Jupiter. We know about its size and its storms and its many moons, but there is an invisible danger surrounding this beautiful planet. Jupiter is wrapped in incredibly powerful and deadly radiation belts. These are areas of space around the planet that are filled with charged particles. Tiny, high-energy electrons and ions that have been trapped by Jupiter's massive magnetic field. They are like Earth's Van Allen belts, but they are thousands of times stronger. An unprotected spacecraft, flying through the most intense parts of these belts, would be destroyed in just a few hours. The radiation would fry its electronics and damage its instruments. Jupiter's largest moons orbit within these radiation belts. Their surfaces are constantly being bombarded by these high-energy particles. This radiation can change the color of the ice on their surfaces, and it would be a huge danger for any future human exploration. To survive in orbit around Jupiter, spacecraft like Juno have to be specially shielded. They are like little armored tanks, built to withstand the invisible storm, or they fly in very careful orbits that loop around the most dangerous areas. So Jupiter is a beautiful king, but a dangerous one. A giant world wrapped in an invisible field of energy that makes it one of the harshest places in the entire solar system. Now, let's think again about the Sun. That great, glowing star that is the heart of our solar system. We talked about how it turns its own mass into energy. But it is hard to truly grasp just how dominant the Sun is. It is not just a little bit bigger than everything else. It is almost everything. The Sun contains more than 99.8% of all the mass in the entire solar system. That means if you took all the planets, all 8 of them, and all of their moons, hundreds of them, and all the millions of asteroids, and all the comets, and all the dust, and you put it all together, all of it would make up less than 1/4% of the solar system's mass. The Sun is everything. Its immense gravity is what holds all of it together. It is what keeps Earth in its gentle, stable orbit. It is what keeps distant comets from flying off into deep space. All the worlds we have talked about tonight are just tiny, tiny leftovers. Little bits of dust and gas that were left behind after the Sun was born. And its great mass is what allows it to create the energy that floods our solar system with light and warmth and makes life on our small, blue world possible. When we think about the planets, we usually think of the 8 big ones: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But beyond Neptune, in the cold, dark reaches of the solar system, there are many other small worlds. These are the dwarf planets. Pluto is the most famous one, but it is not alone. There are others with names like Eris and Haumea and Makemake, and astronomers are constantly finding more candidates. In fact, there may be hundreds or even thousands of dwarf planets waiting to be discovered in the dark out beyond Neptune. These small, round worlds are part of a huge ring of icy objects called the Kuiper Belt. They are ancient relics from when the solar system was first forming. They are too small to be called planets, but they are large enough that their own gravity has pulled them into a round shape. So even though we learned there are 8 planets, the reality is more complex. The solar system is full of worlds of all shapes and sizes. And the number of dwarf planets, the small frozen worlds in the dark, is much, much greater than the number of the big, familiar planets that orbit in the light. Let's return for a moment to the slow, backward world of Venus. We talked about its strange rotation, but it is worth pausing to think about just how slow it is. We know a day on Venus lasts for 243 Earth days, and we know its year, the time it takes to go around the Sun, is only 225 Earth days. This means that a day on Venus is longer than its year. Imagine that. The time it takes for the Sun to return to the same spot in the sky is longer than the time it takes to complete a whole trip around the Sun. This incredibly slow spin is also part of what makes Venus so hot. The side facing the Sun bakes for months at a time, and the thick atmosphere spreads that heat all around the planet, so even the night side never cools down. It is a world of endless, scorching heat, a place where the days are longer than the years, and the Sun moves so slowly across the sky you would never notice it move. Now, let's visit one of the most fascinating moons in the entire solar system. Orbiting the ringed planet Saturn is a large moon called Titan. It is the second largest moon in the solar system, and it is the only moon with a thick, dense atmosphere. Its atmosphere is mostly nitrogen, like Earth's. But what makes Titan so special is what is on its surface. Titan is the only other place in our solar system, besides Earth, where we know there is stable liquid on the surface. There are lakes and rivers and even seas, but they are not made of water. On Titan, it is far too cold for liquid water. Instead, the lakes and rivers on Titan are made of liquid methane and ethane. These are chemicals that on Earth would be a gas, but on cold Titan, they are a liquid. The thick, hazy atmosphere even has weather. There are clouds of methane that can create rain. Methane rain that falls from the sky and fills up the rivers and lakes. Some of these lakes are huge, hundreds of kilometers across, and scientists believe that just like on Europa and Pluto, there might be a secret ocean of liquid water deep beneath Titan's icy surface. So Titan is a world that is strangely familiar. It has clouds and rain and rivers and coastlines, but it is all built from completely alien materials. A cold, hazy world where liquid methane flows under a thick, orange sky. Let's visit Mars one more time and look at its moons. We know Jupiter has dozens of moons, and Saturn does too. Earth has one big moon. Mars has 2. But they are very different from our moon. They are named Phobos and Deimos, and they are tiny. They are not round like our moon. They are small and lumpy, and look like potatoes. They are covered in craters. In fact, they look a lot more like asteroids than they do like traditional moons. And many scientists believe that is exactly what they are. Phobos and Deimos were probably once asteroids, orbiting the Sun in the asteroid belt. A long time ago, they wandered too close to Mars and were captured by its gravity. Their strange, wobbly orbits and their dark, rocky appearance all point to this idea. Phobos is orbiting very close to Mars, so close that it is slowly spiraling inward. Millions of years from now, it will either break apart and form a ring or it will crash into the surface of Mars. Deimos, the smaller and more distant moon, is slowly drifting away. So these two little moons are not permanent companions. They are just quiet, captured travelers passing through Mars's history, on their way to a different fate. Let's travel back out to the king of planets, Jupiter. We know it is a gas giant, far from the sun. You would expect it to be a very cold place. And it is, in its upper atmosphere. But Jupiter has a secret warmth. It actually gives off more heat than it receives from the sun. It glows with its own internal energy. This warmth is not from nuclear fusion, like in the sun. Jupiter is not big enough to be a star. Instead, this heat is leftover energy from when Jupiter was first formed 4.5 billion years ago. As all that gas and dust collapsed together to form the giant planet, a huge amount of gravitational energy was released as heat. And Jupiter is still slowly cooling down from that time. It is also still contracting, very, very slightly. And that slow squeezing generates more heat. This internal warmth is what drives Jupiter's wild weather. It is the engine behind its giant storms, like the Great Red Spot, and its swirling bands of clouds. If you could see Jupiter with an infrared camera, which sees heat instead of light, the planet would be glowing brightly in the dark. It is not a star, but it is almost like a failed one. If it had been just a little bit bigger, it might have been hot enough to start nuclear fusion. And our solar system would have had 2 suns. Now, let's travel to the most distant major planet, Neptune, the deep blue world with the supersonic winds. Unlike all the other planets, which have been known for centuries or even thousands of years, Neptune is a modern discovery, and it was discovered in a very special way. It was found with math. In the 1840s, astronomers were carefully studying the orbit of Uranus, and they noticed something strange. Uranus was not moving exactly as it should. Its path was being gently pulled by something they could not see. There were tiny wiggles in its orbit that could not be explained by the gravity of the Sun and the other known planets. 2 mathematicians, working separately, had the same idea. Maybe there was another planet, a hidden one, far beyond Uranus, and its gravity was gently tugging on Uranus, causing the strange movements. Using only mathematics and the laws of gravity, they calculated where this hidden planet should be. They told astronomers exactly where to point their telescopes, and when they did, there it was, Neptune. It was a huge triumph for science. It showed that the universe followed predictable rules, and that you could discover a new world, not with your eyes, but with your mind. Neptune was the first planet to be found on paper before it was ever seen through glass. A world brought into the light by the quiet power of numbers. Let's go back to the ringed planet Saturn. At its north pole, there is one of the strangest and most beautiful storms in the entire solar system. It is a massive cloud pattern that spins in the shape of a nearly perfect hexagon, a shape with 6 sides. This hexagon is huge. It is more than 30,000 kilometers across, wider than 2 Earths, put side by side. And it has been there for decades, possibly for centuries. Scientists believe this strange shape is formed by a jet stream, a fast, flowing river of air in Saturn's atmosphere. Waves within this jet stream are interacting in just the right way to create this stable, 6-sided pattern. They have even created similar shapes in laboratories by spinning fluids at different speeds. Still, it is amazing to think that such a perfect, geometric shape can form all by itself in the swirling clouds of a distant planet. It is one of the most elegant and mysterious sights in our solar system. A quiet, spinning hexagon at the top of a world. Let's think one more time about our sun. It seems like common sense that the hottest part of the sun would be its center, and the farther out you go, the cooler it should get. And that is mostly true. The core is the hottest part. The surface is cooler. But there is a very strange mystery. The sun's atmosphere, the part above its surface, is actually much, much hotter than the surface itself. The visible surface of the sun is about 5,500 degrees Celsius. But the outer atmosphere, called the corona, can reach temperatures of over 1,000,000 degrees. This has puzzled scientists for a very long time. How can the air above a fire be hotter than the fire itself? There are a few ideas. One is that powerful magnetic waves are carrying energy up from inside the sun and releasing it in the corona. Another idea is that millions of tiny little explosions, called nanoflares, are constantly going off, heating the corona from within. Whatever the reason, the sun's outer layers are glowing with a mysterious, searing heat. A quiet puzzle, shining in the sky, reminding us that even the things we see every day still hold deep secrets. Beyond the orbit of Neptune, we have learned, lies a vast, icy region called the Kuiper Belt. This is where Pluto and the other dwarf planets live. It is a wide ring of trillions of frozen objects, ancient leftovers from when the solar system was formed. Some of these objects are small and rocky, but most are made of ice, water ice, and frozen methane and ammonia. The Kuiper Belt is sometimes compared to the asteroid belt, but it is much, much larger. It is 20 times wider and maybe 200 times more massive. It is a fossil zone of our solar system, a cold, dark, and quiet place where the original building blocks of the outer planets are still preserved, frozen in time. It marks the beginning of the end of the main part of the solar system, a wide, icy boundary before we enter the true depths of space. But the solar system does not end at the Kuiper Belt. Far, far beyond it lies a theoretical and even larger region of space, a place called the Oort cloud. We have never seen it directly. It is too far away, and the objects in it are too small and dark. But scientists believe it is there. The Oort cloud is a giant, spherical shell of icy bodies that surrounds the entire solar system. It is like a huge, thick bubble made of trillions of comets. It extends for an enormous distance, maybe a light year, or even more, out into space. It marks the true edge of the sun's gravitational influence. The objects in the Oort cloud are only very weakly attached to the sun. They are so far away that the gentle gravitational pull of a passing star, or even the Milky Way galaxy itself, can disturb them. And sometimes one of these icy bodies is nudged out of its stable orbit, and it begins a long, slow journey inward toward the sun. When it gets close enough, the sun's heat warms it up, and it grows a long, beautiful tail. It becomes a long-period comet, one of those comets that appears in our skies only once every few thousand years. So the Oort cloud is the birthplace of comets, a distant, dark halo of icy wanderers, quietly circling the very, very edge of our solar system. Let's journey back to the Jupiter system and visit one of its most dramatic moons. Io. It is the most volcanic world in the entire solar system. Its surface is a constantly changing, seething landscape of active volcanoes. It is painted in bright colors of yellow and red and orange and black. These are the colors of sulfur and molten rock. There are hundreds of volcanoes on Io. Some of them are erupting right now. They shoot giant plumes of gas and dust, hundreds of kilometers high into space. This incredible activity is caused by the same thing that warms Europa's ocean: tidal heating. Io is caught in a gravitational tug of war between the massive Jupiter and the other large moons. It is constantly being squeezed and stretched. This friction creates a tremendous amount of heat in its interior. It keeps the rock inside Io in a molten state. So while most moons are cold and icy, Io is a world of fire. Its surface is always new. Any craters that form are quickly buried by fresh lava flows. It is a restless, violent, and beautiful moon with a molten heart. Now we travel to the last major planet, Neptune, and visit its largest moon, Triton. It is a strange and fascinating world. Triton is unique among all the large moons in the solar system because it orbits its planet backward. It moves in the opposite direction to Neptune's rotation. This is called a retrograde orbit. This backward path is a huge clue that Triton did not form around Neptune like the other moons did. It was likely a captured object from the Kuiper belt, a dwarf planet like Pluto that wandered too close to Neptune and was pulled into orbit. This capture would have been a violent event. It probably disrupted any original moons that Neptune might have had. Triton itself is also geologically active. It has a very thin atmosphere, and it has cryovolcanoes, ice volcanoes. These are vents that spew icy materials like nitrogen and methane out onto the surface. So Triton is a cold, distant world, moving the wrong way around its planet. A captured traveler from the edge of the solar system, with a mysterious and active inner life. Now let's think about our own moon, the one we see in our sky almost every night. It seems so normal to us. But Earth's moon is actually unusually large compared to the size of its planet. No other rocky planet in the solar system has a moon that is so big in comparison to itself. Our moon is about 1/4 the diameter of Earth. This is more like the relationship between a dwarf planet and its moon, like Pluto and Charon. Most scientists believe our moon was formed from a giant collision. A long, long time ago, when the Earth was very young, it was hit by another planet-sized body, about the size of Mars. The impact was so powerful, it blasted a huge amount of debris from both bodies out into space. This cloud of debris then went into orbit around the Earth, and over time, gravity pulled it all together to form the moon. This close and large companion has had a huge effect on Earth. Its gravity creates our ocean tides. It has helped to stabilize the tilt of Earth's axis, which gives us our stable climate. So our moon is not just a pretty light in the sky. It is a part of our planet's history, a cosmic partner born from a great collision that helped make Earth the gentle world it is today. We often imagine the planets moving in perfect circles around the sun. But that is not quite right. The orbits of the planets are actually ellipses. They are slightly stretched out circles. This means that during its orbit, a planet is sometimes a little closer to the sun, and sometimes a little farther away. The point where it is closest is called its perihelion. and the point where it is farthest is called its aphelion. For most of the planets, like Earth, this difference is not very big. Our orbit is very close to being a circle. But for some worlds, like Mercury and the dwarf planet Pluto, the orbits are much more elliptical. This stretching out of the orbit affects the planet's speed. A planet moves faster when it is closer to the Sun, and slower when it is farther away. This was first discovered by Johannes Kepler in the 1600s, and it was a huge step in understanding how the solar system works. The planets do not move in perfect, heavenly circles. They follow a more complex, but still very predictable and elegant path. A quiet, elliptical dance around the Sun. Let's think again about the comets. Those icy visitors from the edge of the solar system. We know that many of them come from the distant Oort cloud. These are the long-period comets, the ones that take thousands or even millions of years to make one trip around the Sun. They spend almost all of their lives drifting slowly in the deep, cosmic cold. They are only loosely held by the Sun's gravity, and the gentle pull of a passing star or the tide of the galaxy itself can be enough to nudge them out of their distant orbits. When that happens, some are thrown out of the solar system forever, but others begin the long, slow fall inward toward the Sun. It can take millions of years for them to make this journey. As they get closer, they warm up, and the ice begins to turn to gas, creating the beautiful, glowing tail that we can see from Earth. These comets are like time capsules. They are made of the most ancient, untouched material in the entire solar system. Frozen pieces of the original cloud of gas and dust that everything was made from. Their bright, brief visit to our part of the solar system is a fleeting glimpse of the very beginning of our cosmic home. All things must come to an end. Even stars. Our Sun has been burning steadily for about 4.5 billion years, and it has enough fuel to last for about another 5 billion years. But eventually, the hydrogen fuel in its core will start to run out. When that happens, the Sun will begin to change. It will swell up and become a red giant. It will grow so large it will swallow the inner planets, including Mercury, Venus, and possibly Earth. After this phase, it will shed its outer layers, creating a beautiful, glowing cloud of gas called a planetary nebula. And the small, hot core that is left behind will become a white dwarf, a dense, Earth-sized object made mostly of carbon and oxygen. This white dwarf will no longer be creating energy. It will just be a cooling ember. It will slowly fade over trillions of years until it becomes a cold, dark object. This is the future of our Sun. Not an explosion, but a slow, quiet fading away. The final, gentle end of its long stellar journey. Let's think again about Mars, the red planet. Even though it is much colder than Earth and has a much thinner atmosphere, it still has something very familiar to us. Mars has seasons. Just like Earth, it has spring, summer, autumn, and winter. This is because, just like Earth, Mars is tilted on its axis. Its tilt is about 25 degrees, very similar to Earth's 23 degrees. As Mars orbits the Sun, this tilt means that sometimes its northern hemisphere is pointed more toward the Sun, and sometimes its southern hemisphere is. This is what creates the seasons. The Martian seasons last about twice as long as ours, because Mars takes almost twice as long to go around the Sun. During the Martian winter, the polar ice caps grow larger, and in the summer, they shrink. The changing seasons also affect the weather and are part of what drives the huge dust storms. So even on this distant, quiet desert world, there is a familiar rhythm. A slow, cold cycle of seasons, passing one into the other. Let's go back to Jupiter and its family of moons. The largest of them all is Ganymede. Ganymede is the largest moon in the entire solar system. It is even bigger than the planet Mercury. It is a world of ice, covered in grooves and ridges and old craters. It shows a long history of geological activity, like Europa. Scientists believe Ganymede may have a subsurface ocean of liquid water, sandwiched between layers of ice. But Ganymede has something that no other moon is known to have. It has its own magnetic field. This is a sign that it has a liquid, iron-rich core that is still churning, much like Earth's. This magnetic field is weak, but it is strong enough to create faint auroras, shimmering lights in its very thin atmosphere near its poles. So Ganymede is a world of many layers, a rocky core, a hidden ocean, an icy crust, and its own invisible magnetic shield. A giant moon that is almost like a planet in its own right. Let's visit Pluto again, at the edge of the solar system. We often think of it as always being the most distant world, but that is not always true. Pluto's orbit is very stretched out, very elliptical. And because of this, it sometimes travels closer to the Sun than Neptune. This last happened for about 20 years, from 1979 to 1999. During that time, Neptune was actually the farthest planet from the Sun, and Pluto was the 8th. You might worry that their paths could cross, and they could collide, but they can't. Their orbits are in a special, stable rhythm. For every 3 times Neptune goes around the Sun, Pluto goes around exactly twice. This gravitational dance keeps them safely apart. Their paths never actually cross. It is a quiet, perfect timing that keeps these 2 distant worlds in a safe and predictable embrace. Our Sun has a magnetic field, a huge, complex field that extends far out into the solar system. But this magnetic field is not stable. It changes over time. Roughly every 11 years, the Sun's entire magnetic field flips over. The North Magnetic Pole becomes the South Magnetic Pole, and the South becomes the North. This process is called the solar cycle. It is tied to the churning, flowing motion of the hot gas deep inside the Sun. This cycle affects how active the Sun is. When the magnetic field is at its most complex and tangled, in the middle of the cycle, we see more sunspots and more solar flares. This is called the solar maximum. When the field is simpler, we see less activity. This is the solar minimum. These cycles have a small but measurable effect on Earth. They can affect satellites and communications. And they are why the auroras are sometimes stronger and more frequent. The Sun's magnetism is not a steady thing. It breathes. It pulses and flows in a slow 11-year rhythm, like a giant magnetic heartbeat. It is a common idea in stories and myths that when the planets line up in the sky, it can cause disasters on Earth, earthquakes or floods. But in reality, this is not true. There is no scientific evidence that planetary alignments have any effect on us at all. The reason is gravity. Gravity gets weaker very quickly with distance. Even a huge planet like Jupiter is so far away from Earth that its gravitational pull on us is tiny. The Moon, because it is so close, has a much stronger gravitational effect on Earth than all the other planets combined. the Sun's gravity is even stronger. So even when all the planets are on the same side of the Sun, their combined extra pull on the Earth is so small, it is completely unnoticeable. Planetary alignments are beautiful to see in the sky, but they are just a trick of perspective. A quiet, harmless dance of distant worlds. Our solar system is huge, and leaving it is a very long journey. The Voyager 1 and 2 spacecraft were launched in the 1970s. They are two of the farthest human-made objects from Earth. They have been traveling outward for more than 40 years. They are moving at incredible speeds, over 60,000 kilometers per hour. And only recently have they finally crossed the boundary where the Sun's influence gives way to the space between the stars. This boundary is called the heliopause. It is where the solar wind, the stream of particles from the Sun, is no longer strong enough to push back the thin gas of interstellar space. The Voyager probes are now sailing in that interstellar medium. They are still sending back faint signals, telling us what it is like in the space between the stars. On board, they each carry a golden record, a disc filled with sounds and music and images of Earth. A quiet message to any other travelers who might find them in the distant future. They are our silent ambassadors to the vast galaxy beyond our home. We have talked about Earth's magnetic field, that invisible shield that protects us. It is generated by the moving, molten iron in our planet's outer core, and its job is to deflect the charged particles that are always streaming from the Sun. This is the solar wind. Without this shield, the solar wind would slowly, but surely, strip away our atmosphere. This is likely what happened on Mars, which once had a thicker atmosphere, but lost its global magnetic field long ago. Our magnetic field is what has allowed Earth to keep its oceans and its air for billions of years. It also creates one of the most beautiful sights on Earth, the auroras, the northern and southern lights. Some of the solar wind particles are not completely deflected. They are funneled down along the magnetic field lines near the poles. When they hit the atoms and molecules in our upper atmosphere, they make them glow, creating shimmering curtains of green and red and violet light. So this invisible shield not only protects us from harm, it also creates a quiet, beautiful light show in the night sky. Let's look up at our moon again, that big, beautiful companion that lights up our nights. It seems like it has always been there and always will be. But its orbit is not permanent. The moon is slowly, very slowly, moving away from the Earth. Every year, it drifts about 3.8 centimeters farther away, about the speed your fingernails grow. This is caused by the tides. The moon's gravity pulls on Earth's oceans, creating a bulge of water. As the Earth spins, this bulge of water is slightly ahead of the moon, and the gravity of this bulge gently pulls the moon forward, giving it a little bit of energy. This extra energy makes the moon's orbit get a little bit bigger. In the very distant past, the moon was much closer to the Earth. It would have looked huge in the sky. And as it slowly moves away, our days are actually getting a tiny bit longer. Billions of years from now, the moon will be so far away that it will no longer be big enough in the sky to completely cover the Sun. Total solar eclipses will no longer happen. The sky is always changing, even if the change is so slow that we will never feel it. Out in the Kuiper belt, beyond Neptune, are the small, icy worlds. We have learned that some of them, like Pluto, are covered in frozen nitrogen. But some of the other dwarf planets are surprisingly bright. Eris, for example, is one of the most reflective objects in the entire solar system. It reflects almost all the sunlight that hits it. It is brighter than fresh snow. Another dwarf planet, Haumea, is shaped like a football because it spins so fast, and its surface is coated in a layer of pure, crystalline water ice, like a mirror in the deep darkness. At the very edge of the solar system, where the sunlight is 1,000 times fainter than it is here, some of these distant worlds are gleaming like polished jewels, catching the faint, distant sunlight in their perfect frozen silence. Let's visit Saturn's system one more time and look at one of its smaller moons, a tiny moon called Enceladus. It is small and covered in bright, clean ice, but this little moon is hiding a huge secret. At its south pole, there are cracks in the ice, long, deep cracks that are called tiger stripes, and from these cracks, enormous geysers are erupting, blasting plumes of water vapor and ice crystals out into space. These plumes shoot up for hundreds of kilometers. They are powered by the same tidal heating that warms Europa. Saturn's gravity is squeezing and stretching Enceladus, creating enough heat to maintain a liquid ocean deep beneath its icy shell. And this ocean water is finding its way up through the cracks and erupting into space. The Cassini spacecraft flew right through these plumes, and it found that they contain not just water, but also salts and organic compounds, and even tiny grains of silica, which on Earth is a sign of hot water interacting with rock, like at hydrothermal vents on the bottom of our oceans. This makes Enceladus one of the most exciting places to search for life. It has liquid water, it has organic chemistry, and it has an energy source. All the ingredients we think are necessary for life. And some of the ice from these plumes escapes the moon completely and becomes part of Saturn's E-ring. So this little moon is feeding one of its planet's rings with its own hidden ocean. Let's go back to the asteroid belt for a moment. We learned that many asteroids are solid rock, but not all of them. Some asteroids are not solid at all. They are just loose collections of rocks and gravel and dust. They are often called rubble piles. They are held together only by their own very weak gravity. These fragile bodies probably formed after a collision shattered a larger, solid asteroid. And then the pieces slowly, gently, came back together over time. These rubble pile asteroids can have strange properties. They can have large empty spaces inside them. They can spin in odd ways. And they can even change their shape if they are spun up too fast. Spacecraft have visited some of these asteroids and confirmed their loose, porous nature. They are not single, solid objects. They are chaotic, drifting piles of ancient ruins, barely holding themselves together as they make their quiet orbit around the Sun. Let's visit Mercury again, the little planet closest to the Sun. It is a small planet, but it has a very big secret: its core. Mercury has an iron core that is unusually large for its size. It makes up about 80% of the planet's entire radius. This is a much bigger proportion than the core of Earth or Venus. Scientists are not sure why its core is so oversized. One theory is that Mercury used to be a much larger planet with a thick, rocky mantle, but a giant impact early in its history blasted away most of that rocky layer, leaving behind the dense, heavy core with just a thin layer of rock on top. Another idea is that Mercury formed very close to the young sun, and the sun's intense heat and solar wind vaporized and blew away the lighter rocks, leaving the heavier metals behind. Whatever the reason, Mercury is a planet that is mostly made of metal. A small, dense world with a giant iron heart. We know that many of the planets have moons. Earth has one. Mars has two. The giant planets have dozens. But not every planet has a companion. Among the rocky inner planets, both Mercury and Venus are without any moons at all. For Mercury, it is probably because it is so close to the Sun. The Sun's gravity would make it very difficult for a moon to stay in a stable orbit around Mercury. But Venus's situation is more of a puzzle. It is about the same size as Earth. It should be able to hold on to a moon. Some scientists think it might have had a moon once, but it was destroyed. Maybe it crashed back into the planet. Or maybe a large impact knocked it out of orbit. Other theories suggest that Venus's very slow, backward rotation makes it hard for stable moon orbits to form. Whatever happened, Venus now travels alone. A bright cloud-covered world with no moon to light up its long, dark nights. In our solar system, most of the moons belong to the giant planets, while the four inner, rocky planets have only 3 moons between them. The 4 outer gas giants have more than 200. Jupiter and Saturn are the champions. Each of them has a huge collection of moons, ranging from giant worlds like Ganymede and Titan to tiny captured asteroids. Uranus and Neptune also have many icy moons. These giant planets act like gravitational anchors in the outer solar system. Their immense gravity was able to capture passing objects and hold on to the material that formed their large satellite systems. So the farther you go from the Sun, the more moons you find. A quiet reminder that gravity likes to gather companions in the cold and the dark. For over 30 years, the Hubble Space Telescope has been orbiting the Earth. It has taken some of the most famous and beautiful pictures of distant galaxies and nebulas. But Hubble also looks at our own solar system. From its perch high above Earth's atmosphere, it can take incredibly sharp and clear images of our neighboring planets. It has watched the cloud bands on Jupiter change over time. It has seen new, dark storms appear on Neptune, and it has monitored the changing seasons on Mars as the polar caps grow and shrink. These long-term observations are very valuable. They let us see how the planets change over many years, something a brief flyby mission cannot do. So from its quiet orbit, just a few hundred miles above us, Hubble keeps a steady watch. Not just on the distant universe, but also on the shifting, changing faces of our closest celestial neighbors. Let's look at Jupiter's most famous feature, the Great Red Spot. It is a giant, swirling storm in Jupiter's southern hemisphere. A storm so huge, it could swallow the entire Earth with room to spare. It is a hurricane that has been raging for centuries. We have been observing it with telescopes for at least 350 years, and it was likely going long before that. The storm has changed over time. In recent decades, it seems to be shrinking, but it is still incredibly powerful. Its reddish color is still a mystery. It might be caused by complex chemicals in Jupiter's upper atmosphere being exposed to sunlight. The winds along its edges blow at more than 400 kilometers per hour. On Earth, the biggest storms last for days, or maybe weeks. But this great Jovian storm has lasted for lifetimes. Trapped between two of Jupiter's powerful jet streams, it continues to spin, a deep, red eye in a sea of swirling clouds. Let's travel back to Neptune, the distant blue world. We know it has the fastest winds, powered by its own internal heat. And just like Jupiter, Neptune gives off more energy than it gets from the Sun. It radiates about 2.5 times more heat than it receives. This internal furnace is what drives its incredibly active weather. The source of this extra heat is still not perfectly understood. It is probably a combination of things. Some of it is leftover heat from when the planet was formed, and some of it is likely generated by the planet slowly contracting under its own immense gravity. Whatever the cause, Neptune is a surprisingly energetic world. Despite being so far from the Sun, in the deep, cold darkness, it is not a quiet, frozen ball. It is a world with a cold face and a warm heart, an internal engine that is always churning and reshaping its windswept, blue atmosphere. Of all the worlds we have visited tonight, our own Earth remains unique. And one of the most special things about it is water. Other worlds have water. We have found ice on Mercury and Mars and many moons. We believe there are hidden oceans on Europa and Enceladus, and maybe even Pluto. But Earth is the only planet we know of where water exists naturally in all three of its states: solid, liquid, and gas. We have solid ice at the poles and in glaciers. We have liquid water in our vast oceans and lakes and rivers. And we have water vapor as a gas in our atmosphere, forming clouds. This perfect balance is possible because of Earth's distance from the Sun and its atmospheric pressure. We are in the just right zone, not too hot and not too cold. On other worlds, water is usually just in one state, frozen solid or baked into vapor. But on Earth, it flows and freezes and evaporates in a constant life-giving cycle. The dance of water is the dance of life, and it is a dance that so far we have only found on our own pale blue dot. We have talked about the heliopause, that final boundary where the Sun's solar wind fades away. This is the edge of the Sun's energetic influence. As the solar wind flows out from the Sun, it creates a huge bubble in interstellar space. This bubble is called the heliosphere, and all the planets and asteroids and comets are inside this protective bubble. The heliosphere acts like a shield. It protects us from the harshest cosmic rays that come from deep space. Beyond this bubble is the interstellar medium, the thin gas and dust that fills the space between the stars. The Voyager probes crossed this boundary, and they found that the level of cosmic rays jumped up significantly. So the Sun does not just give us light and heat. It also creates a safe harbor for us in the galaxy, a quiet bubble that it blows with its own breath, sheltering us as we drift through the silent space between the stars. Our solar system is not sitting still. It is moving. The whole solar system, the Sun, and all the planets are traveling through a region of space called the local interstellar cloud. This is a thin, wispy cloud of gas and dust, about 30 light-years across. It is just one small cloud in a much larger, emptier region called the local bubble, which was probably carved out by ancient supernova explosions. We are sailing through this thin fog at about 70,000 kilometers per hour, The sun's heliosphere, that protective bubble, is what shields us from this interstellar material. It acts like the bow of a ship, pushing the gas and dust aside. So we are not just orbiting the sun. We are all on a much larger journey. A slow, silent voyage through the changing weather of the galaxy itself. We often think of geology as something that happens on planets, volcanoes and earthquakes and moving continents. But many moons in the solar system are also geologically active. They are not just dead, frozen balls of rock and ice. We have seen Io with its fiery volcanoes, and Enceladus with its watery geysers. Europa's icy shell is likely moving and cracking. Even Triton, Neptune's cold, captured moon, has ice volcanoes that erupt with nitrogen frost. All of these moons are powered by internal heat, usually from the constant gravitational squeezing of their parent planet. This shows us that the conditions for an active world can exist in many different places. You don't need to be a big planet to have a warm heart. Even small, distant moons can be restless worlds with changing surfaces and hidden secrets deep beneath their frozen exteriors. Let's visit Pluto one last time. This small, cold world has a very thin atmosphere. It is made mostly of nitrogen with a little bit of methane and carbon monoxide. But Pluto's atmosphere is not permanent. It comes and goes. Pluto's orbit is very elliptical, so for part of its long year, it is closer to the Sun. During this time, the faint sunlight is just strong enough to warm the frozen nitrogen on its surface, and some of it turns directly into a gas, forming a thin, hazy atmosphere. But as Pluto moves farther away from the Sun on its long journey outward, it gets colder again. And that thin atmosphere freezes. It snows back down onto the surface like a frost, and the atmosphere disappears for a very long time. This cycle repeats over Pluto's 248-year orbit. When the New Horizons spacecraft flew by in 2015, it was good timing. Pluto was still relatively close to the Sun, and its atmosphere was still there. We saw it as a beautiful, layered blue haze around the edge of the world, a fleeting, temporary breath around a tiny planet that spends most of its life in a deep, breathless winter. Deep in the Sun's core, the temperature is almost unimaginable, over 15 million degrees Celsius. Here, the pressure is so intense that the very atoms themselves are crushed together. This is where nuclear fusion happens. Hydrogen is turned into helium, and that is what powers the Sun. The energy that is released in the core, in the form of light particles called photons, does not travel straight out. The inside of the Sun is so dense that a photon can only travel a short distance before it is absorbed and then emitted in a random direction. It bounces around from atom to atom on a long, drunken walk. It can take hundreds of thousands of years for the energy created in the core to finally make its way to the Sun's surface. Once it escapes the surface, it travels in a straight line across the vacuum of space. It takes just over 8 minutes for that light to travel all the way to Earth. So the sunlight that is warming your face right now was created in the Sun's core, perhaps before humans even existed. It spent a huge amount of time just getting to the surface, and then it made the final, fast journey across space to us. We know that Saturn has rings, but it is not the only planet with them. Uranus also has a system of rings, 13 of them that we know of. They are very different from Saturn's rings. They are much darker and much fainter. They are made of very small particles of rock and ice that are coated in a dark material. And just like the planet itself, the rings are tilted on their side. They circle the planet vertically, like a target standing on its edge. These rings were not discovered until 1977, and they were found by accident. Astronomers were watching Uranus as it was about to pass in front of a distant star. They were hoping to study the planet's atmosphere. But before the planet got to the star's light blinked out several times. And after the planet passed, it blinked out again in a matching pattern. They realized they had found a system of thin, dark rings that were blocking the starlight. They are subtle, shadowy bands circling a sideways world. We have talked about the heliosphere, that giant magnetic bubble that the sun blows around the entire solar system. This bubble is not stationary. It is moving through the galaxy along with the sun, and its shape is influenced by the interstellar medium it is moving through. It is not a perfect sphere. It is more like a comet. It has a rounded nose in the direction it is traveling, and a long, extended tail streaming out behind it. The heliosphere is our shield. It protects the planets from the high-energy galactic cosmic rays that are created by distant supernovas. Without it, the level of radiation in the solar system would be much higher, and it would be much harder for life to exist. So as the sun journeys around the Milky Way, it carries its protective bubble with it. A quiet, magnetic shield that shelters all the worlds that call it home. Let's travel back to Mercury, the smallest planet. For a long time, there was a small mystery about its orbit. Astronomers noticed that its orbit was not perfectly stable. It was slowly shifting over time. The point of its closest approach to the Sun was moving a tiny bit with each orbit. Newton's theory of gravity could explain most of this shift, but not all of it. There was a tiny, unexplained wobble. In 1915, Albert Einstein published his theory of general relativity. His new theory of gravity was different from Newton's. Einstein said that massive objects, like the Sun, do not just pull on other objects. They actually warp and curve the fabric of space and time around them. And planets are just following that curve. When he calculated how Mercury's orbit should behave in this curved space-time, his theory predicted the tiny wobble exactly. It was one of the first great proofs that Einstein's new theory was correct. A quiet little quirk in the motion of a tiny, scorched planet helped to change our entire understanding of the universe. The ocean tides on Earth, the daily rise and fall of the sea, are caused by gravity, and mostly by the gravity of the moon. The moon's pull is slightly stronger on the side of the Earth that is facing it, and slightly weaker on the far side. This difference in pull stretches the Earth a little bit, and because the water in the oceans can move, it creates two bulges, one on the side facing the moon, and one on the side opposite the moon. As the Earth rotates, we pass through these two bulges each day, and this is what creates the high and low tides. The Sun also has an effect on the tides. But even though the Sun is much more massive, it is so much farther away that its tidal effect is less than half of the Moon's. So it is our close and large Moon that is the master of the tides. Its silent, invisible pull is what keeps the great oceans of our world in constant, rhythmic motion. We have learned about the planets and the dwarf planets out in the Kuiper belt. But are there any other big planets hiding in the dark? It is possible. Astronomers have noticed that some of the most distant objects we have found in the Kuiper belt have strange orbits. They all seem to be clustered together and tilted in the same way. It is as if they are all being gently herded by the gravity of something big and unseen. One theory is that there could be another large planet out there, a ninth major planet. If it exists, it would be much larger than Earth, and it would be on a huge, elongated orbit, far, far beyond Neptune and Pluto. It would take thousands of years to make just one trip around the Sun. No one has seen this planet. It is still just an idea, a ghost in the mathematics. But telescopes are searching for it, looking for a faint, slow-moving point of light in the deep darkness. A hidden world that might be quietly shaping the very edge of our solar system. Let's visit Jupiter's family of moons one last time and look at the most distant of the 4 large Galilean moons, Callisto. Its surface is very old and dark and covered in craters. It is the most heavily cratered object in the entire solar system. This tells us that its surface has not changed much for billions of years. It does not have active volcanoes or moving ice plates. But beneath this ancient, quiet surface, Callisto might be hiding the same secret as its neighbors. A subsurface ocean. Magnetic field data from the Galileo spacecraft hinted that there could be a layer of salty, liquid water deep beneath the ice. It would be kept liquid by the leftover heat from the moon's formation and the same tidal forces from Jupiter that warm the other moons. If the ocean is there, it is buried very deep under a thick, cold lid of ice. But it would mean that almost all of Jupiter's large moons are ocean worlds. Even this quiet, ancient moon that looks so still on the outside may have a deep, dark sea, silently sealed beneath a shell of ice and time. Let's think one more time about the 2 sister planets, Venus and Earth, and the puzzle of their temperatures. Mercury is the closest planet to the Sun, so you would think it would be the hottest. But it is not. Venus is the hottest planet in the solar system, even though it is farther from the Sun than Mercury. The reason is its atmosphere. Venus has an incredibly thick, dense atmosphere, made almost entirely of carbon dioxide. This carbon dioxide acts like a thick, heavy blanket. It lets the sunlight in, but it does not let the heat back out. This is the greenhouse effect, and on Venus, it has run away, out of control. The surface temperatures are over 460 degrees Celsius, hot enough to melt lead. Mercury, on the other hand, has almost no atmosphere at all. So while its sunny side gets very hot, that heat radiates right back out into space, and its night side gets incredibly cold. Venus's crushing heat is a powerful reminder. The temperature of a planet is not just about how close it is to its star. It is about its atmosphere and the quiet, powerful ability of gas to trap heat. The beautiful rings of Saturn are made of countless individual pieces, and we have learned that those pieces are made mostly of water ice. They range in size from tiny specks of dust to chunks as big as a car or a house. This ice gives the rings their amazing brightness. They reflect sunlight very well, which is why they are so easy to see, even from Earth. Within the rings, there are gaps and waves and strange, braided patterns. These are all created by the complex gravitational dance between the ring particles themselves and Saturn's many moons. The rings are a dynamic and always changing place, a giant, flat river of ice constantly being sculpted by the silent pull of gravity. In the asteroid belt between Mars and Jupiter sits the largest object in that region, Ceres. For a long time, it was just considered the biggest asteroid. But it is special. Ceres is so large that its own gravity has pulled it into a nearly perfect spherical shape. And because of this, it is also classified as a dwarf planet. It is the only dwarf planet in the inner solar system. The Dawn spacecraft orbited Ceres for several years, and it found a dark, cratered world, but with mysterious, bright spots. These bright spots turned out to be deposits of salt. They are probably the leftovers of a briny, salty liquid that came up from inside Ceres and then evaporated, leaving the bright salt behind. This suggests that Ceres may have, or had in the past, a layer of muddy, salty water beneath its surface. So Ceres is a bridge, not quite a planet, but more than just an asteroid. A small, round world that shows us the kinds of ingredients that were available when the planets were first being formed. When we look at Mars, we see red, the red planet. That color comes from rust. The surface of Mars is covered in a fine dust that is rich in iron, the same element that makes up our blood and our planet's core. Over billions of years, the iron in the Martian soil has reacted with small amounts of oxygen in the atmosphere, and it has oxidized. It has rusted. This fine, red dust is everywhere. It covers the rocks. It fills the craters. And it gets kicked up into the atmosphere, giving the Martian sky a pale, pinkish color. So the color of Mars is the color of old age, the color of a world that has been slowly, quietly rusting for billions of years. The surface of our sun is a churning, boiling sea of hot gas. But sometimes, darker, cooler patches appear on its surface. These are sunspots. They look dark only because they are cooler than the incredibly bright area around them, but they are still extremely hot. Thousands of degrees. Sunspots are temporary. They can last for days or weeks. They are caused by the sun's powerful magnetic field. In these areas, the magnetic field becomes very strong and tangled, and it pokes through the surface. This strong magnetic activity stops the normal flow of heat from inside the sun from reaching the surface. So that spot cools down a little bit. Sunspots often appear in pairs or groups, and their number follows the 11-year solar cycle. They are like magnetic storms on the surface of the sun, visible signs of the quiet, invisible churning that is always happening deep inside our star. The planet Uranus was discovered in 1781 by the astronomer William Herschel. He was using a new, powerful telescope that he had built himself. At first, he didn't know what it was. He thought it might be a comet or a strange star. But as he watched it over several nights, he saw that it was moving slowly against the background of stars. It was a planet. The first planet to be discovered since ancient times. It was a huge moment in astronomy. It doubled the known size of the solar system. And it showed that there were more worlds out there than the ones we could see with our own eyes. It was the beginning of a new era of discovery, one where powerful telescopes would help us to explore the vast and quiet spaces of our cosmic neighborhood. Our solar system has a birthday. By studying the age of the oldest rocks on Earth and moon rocks, and especially ancient meteorites, scientists have been able to figure out how old our solar system is. It is about 4.6 billion years old. It began as a huge, swirling cloud of gas and dust, a solar nebula. Slowly, gravity pulled this cloud together. Most of the material fell into the center and became so hot and dense that it ignited and became the sun. The leftover material, the last little bit, formed a flat, spinning disk around the young sun. And in this disk, tiny grains of dust and ice stuck together. They grew into pebbles, then rocks, then boulders, and finally into the planets and moons and asteroids that we see today. The worlds we have visited tonight are the quiet survivors of that chaotic and creative beginning. Back in the asteroid belt, there is another special object, Vesta. It is the second largest object in the belt after Ceres, and Vesta is like a miniature planet. It has a layered structure just like Earth. It has a dense, metallic core, a rocky mantle around the core, and a crust on the surface. This means that very early in its history, Vesta was hot enough to be completely molten, and the heavier materials, like iron, sank to the center, while the lighter rocks floated to the top. This process is called differentiation, and it is something that happens to planets. So Vesta is a protoplanet, a baby planet that never finished growing. A fossil from the very beginning of the solar system that shows us what the insides of the rocky planets might have looked like when they were just beginning to form. Our moon looks so quiet and still, but it is not completely dead geologically. The moon has quakes, moonquakes. They are much weaker than earthquakes on Earth, but they happen. Data from the seismometers left on the moon by the Apollo astronauts showed that the moon trembles. Some of these quakes are caused by the tidal pull of Earth's gravity, stretching and squeezing the moon. Some are caused by meteorite impacts, and some seem to come from deep inside the moon, suggesting that parts of its interior may still be warm and partially molten. Moonquakes also last much longer than earthquakes. Because the moon is so dry and rigid, the vibrations can ring through it like a bell for up to an hour. So the moon is not a completely cold and silent rock. It has a quiet, beating heart deep inside. Let's return to Neptune and its big moon, Triton. We learned that it is a captured object from the Kuiper Belt. And that capture was a dramatic event. It probably destroyed any moons that Neptune had before, and it would have thrown Triton into a very strange and unstable orbit. Over a very long time, the tidal forces between Neptune and Triton would have circularized its orbit. But that process would have created a huge amount of heat inside Triton, enough to melt its interior and keep it geologically active for a very long time. So the strange, icy volcanoes on Triton today may be a direct result of its violent capture billions of years ago. It is a moon shaped by a chaotic past, a quiet, frozen world that still carries the memory of fire. Neptune, the last of the giant planets, has 14 known moons. Triton is by far the largest, making up almost all of the total mass of Neptune's moon system. The other 13 moons are all very small and dark and icy. Some of them orbit very close to the planet within its faint ring system. Others are on strange, distant and irregular orbits. Like Jupiter and Saturn, these small outer moons are likely captured objects from the Kuiper Belt. They form a scattered and diverse family, a quiet collection of companions around the last and most distant of the great planets. In 2018, NASA launched a mission called the Parker Solar Probe. Its goal is to do something that has never been done before: to touch the Sun. The spacecraft is flying closer to the Sun than any object in history. It actually flies through the Sun's outer atmosphere, the corona. To survive, it is protected by a thick carbon heat shield that can withstand temperatures of over 1,000 degrees Celsius. On each orbit, it dips a little closer. It is moving at incredible speeds, faster than any human-made object has ever flown. Its mission is to help us understand the mysteries of the Sun, like why the corona is so hot, and how the solar wind is accelerated. It is not just looking at the Sun from a distance. It is flying right through the storm, a brave little messenger. In the heart of the fire, we know that Mars is millions of miles away. But did you know that you can hold a piece of Mars in your hand? There are meteorites on Earth that have come from Mars. A long time ago, a large asteroid or comet crashed into Mars. The impact was so powerful, it blasted pieces of Martian rock out into space with enough speed to escape the planet's gravity. These rocks then drifted through the solar system for millions of years, until some of them crashed into Earth. Scientists can identify them because they have a chemical makeup that is different from Earth rocks, but a perfect match for the rocks analyzed by rovers on Mars. Some of them even have tiny bubbles of gas trapped inside them. And that gas is a perfect match for the Martian atmosphere. These quiet, wayward stones are little pieces of another world, sent to us by a random collision, long before we ever had the technology to go there and get them ourselves. The Sun is mostly made of two things: hydrogen and helium, the two simplest and lightest elements in the universe. About 70% of the Sun's mass is hydrogen. Most of the rest is helium. These are the same elements that the universe was mostly made of right after the Big Bang. The remaining 1 or 2% is a mix of all the other heavier elements: oxygen, carbon, iron. These heavier elements were created inside earlier generations of stars that lived and died before our Sun was born. So even though our Sun seems so powerful and complex, it is made of very simple things. A giant, glowing ball of the most basic ingredients in the entire cosmos. The reason we have seasons on Earth is because our planet is tilted. The axis that the Earth spins on is not perfectly upright. It is tilted by about 23.5 degrees. This tilt means that as we orbit the Sun, sometimes the northern hemisphere is tilted more toward the Sun. This gives us more direct sunlight and longer days, and so we have summer. At the same time, the southern hemisphere is tilted away from the Sun, so it has winter. Half an orbit later, the situation is reversed. If the Earth was not tilted, the climate would be very different. The equator would always be hot. The poles would always be cold, and there would be no seasons in between. So this gentle, quiet tilt is the simple reason for the changing rhythms of our year. Jupiter's magnetic field is the strongest of any planet, and it creates a huge magnetic bubble around Jupiter, called its magnetosphere. This magnetosphere is the largest single structure in the entire solar system. If you could see it with your eyes from Earth, it would appear bigger than the full moon. It is so big, it stretches for millions of kilometers. It is powered by the rapid rotation of Jupiter, and the electric currents generated in the liquid metallic hydrogen deep inside the planet. This giant magnetic field traps particles, creates powerful auroras, and interacts with Jupiter's moons. It is a vast and invisible empire, ruled by the magnetic power of the giant planet at its center. We see rings around Saturn and Jupiter and Uranus and Neptune. They look so ancient and permanent, but planetary rings may be a temporary feature in the life of a solar system. Rings can be formed when a moon gets too close to a planet and is torn apart by gravity, or when two moons collide. But over millions of years, the material in the rings can be lost. It can be slowly pulled into the planet, or it can be swept up by small moons, or it can clump together to form new small moons. We know that Saturn's rings are relatively young and may disappear in the future. So the beautiful rings we see today may just be a passing phase, a fleeting, shimmering moment in a planet's long and quiet life. The surface of our moon has barely changed in billions of years. Because there is no wind and no rain and no active geology, there is almost nothing to erode it. The footprints left by the Apollo astronauts will still be there thousands of years from now. The only thing that really changes the lunar surface is the constant, slow rain of micrometeorites and the bombardment of radiation from the sun. This process is called space weathering, and it very, very slowly darkens and softens the lunar soil. The big craters we see are scars from ancient impacts. From the early days of the solar system, the moon is like a museum, a quiet and faithful record of our corner of the universe's long and sometimes violent history. We have learned about the possibility of hidden oceans on moons like Europa and Enceladus. And scientists believe that on the floor of these dark, alien oceans, there could be hydrothermal vents. These are cracks in the seafloor where hot, mineral-rich water is flowing out from the moon's rocky interior. On Earth's ocean floors, these same kinds of vents support entire ecosystems of life. Creatures that live in total darkness and get their energy not from the sun, but from the chemical reactions in the hot water. If these vents exist on other worlds, they could be a perfect place for life to begin. They provide water, heat, and a steady source of chemical energy. The plumes from Enceladus have already shown us that these kinds of reactions are likely happening. So deep beneath the ice, on these distant moons, there may be warm, dark gardens of life, quietly thriving in the heart of a cold, silent world. The light from the sun seems to arrive instantly, but it does not. It takes time to travel across the vast distance between the sun and the Earth. About 150 million kilometers, light travels incredibly fast. But space is very big. The light from the sun takes just over 8 minutes to reach us. This means that when you look at the sun, you are not seeing it as it is right now. You are seeing it as it was 8 minutes ago. You are looking into the past. The sunlight that warms the morning began its journey while you were still in the deepest part of the night. The cracked, icy surface of Jupiter's moon Europa is covered in lines and ridges. It suggests that the ice shell is not one solid piece. It may be broken up into plates that are moving and sliding around, similar to the tectonic plates on Earth. If this is true, it would be the only other world we know of with this kind of active, plate-like motion. This movement could be very important. for the possibility of life in its ocean. It could help to carry nutrients and chemicals from the surface down into the water below. The driving force is likely the constant flexing from Jupiter's gravity. A slow, steady churning that keeps this frozen world from being completely still. Saturn is the second largest planet. It is a true giant. But it is also the lightest planet for its size. It is the least dense planet in our solar system. It is made mostly of hydrogen and helium, the lightest gases. Its average density is actually less than water. This means that if you could find a bathtub big enough to hold it, Saturn would float. Its huge size and low density, along with its fast rotation, makes the planet bulge out at its equator and get flattened at its poles. It is not a perfect sphere. It is a soft, puffy giant, gently shaped by gravity and its own rapid spin. The sun is not always calm. Sometimes it has eruptions. Solar flares are sudden, intense bursts of energy from the sun's surface. They are often connected to sunspots. These flares release huge amounts of radiation into space. When a powerful flare is aimed at Earth, it can affect us. It can disturb our upper atmosphere and mess with radio communications and GPS signals. In very extreme cases, it can even damage power grids on the ground. Our magnetic field and atmosphere protect us from most of the harm. But these flares are a reminder that our sun is not just a steady, gentle light. It is a dynamic and sometimes violent star. One that occasionally sends powerful waves of energy pulsing out across the solar system. The beautiful auroras, the northern and southern lights, are directly connected to the sun's activity. They are caused by solar particles hitting our atmosphere. So when the sun is more active, during the solar maximum of its 11-year cycle, the auroras become more frequent and more spectacular. More solar flares and coronal mass ejections send more particles our way. And our magnetic field funnels them toward the poles, creating brighter and more widespread light shows. During the solar minimum, the auroras are quieter. The sun's magnetic weather ripples all the way across the solar system, and we can see its effects, painted in soft, glowing colors in our own night sky. When a comet gets close to the sun, it grows a tail, or actually, two tails. And these tails do not trail behind the comet, like smoke from a chimney. They always point away from the sun, no matter which way the comet is moving. One tail is the dust tail. It is made of tiny dust particles that have been pushed away from the comet by the pressure of sunlight itself. This tail is often curved. The other tail is the iron tail. It is made of gas that has been stripped of its electrons by the sun's ultraviolet light. This tail is pushed straight back by the solar wind. It often glows with a blue color. So a comet's tail is like a cosmic windsock. It doesn't show where the comet has been. It shows where the sun is. A luminous arrow pointing away from the light. We know that many moons were captured asteroids or formed alongside their planets. But we also know that some moons were born in violence. Our own moon was likely formed from a giant impact, and Pluto's largest moon, Charon, may have been created in the same way. A huge collision that almost destroyed the young Pluto. The diversity of how moons are made shows us how chaotic and creative the young solar system was. Some moons were born in fire and chaos. Others were gathered gently by gravity. Each one tells a different story of its own quiet beginning. The Voyager 1 spacecraft, launched in 1977, is now the most distant human-made object. It is flying through interstellar space. Attached to its side is the Golden Record, a phonograph record made of gold-plated copper. It contains sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 languages. There is music from different eras and cultures. And there are the sounds of nature, wind and rain, and the songs of birds and whales. It was designed by a team led by Carl Sagan as a message in a bottle, a greeting to any other civilization that might find it in the far distant future. A quiet, hopeful whisper from our small blue world. Our planet Earth is not completely alone in its orbit. It shares its path around the Sun with a few small companions. These are co-orbital asteroids. They don't orbit the Earth like the Moon. Instead, they follow complex, looping paths near Earth's orbit, held in place by the combined gravity of the Sun and the Earth. Some of them, called Trojans, are trapped in stable points, either ahead of or behind the Earth in its orbit. Others follow a strange, horseshoe-shaped path that brings them close to the Earth and then sends them away again. These companions are usually very small and are often temporary visitors, captured for a few thousand years before they drift away again. They are our silent, invisible neighbors, fellow travelers on our long, yearly journey around the Sun. Before Neptune was officially discovered, it may have been seen by astronomers who didn't know what they were looking at. Even the great astronomer Galileo may have recorded it in his notes in 1612. He marked it down as a faint star. Because it moves so slowly and is so far away, it is very easy to mistake for a star. It wasn't until astronomers started looking for a reason for the strange wobbles in Uranus's orbit that they knew to look for a planet. So for centuries, Neptune was hiding in plain sight, a quiet, blue world, waiting patiently in the darkness to be discovered. The edge of our solar system is not a hard line. It depends on what you are measuring. If you are measuring the Sun's gravity, then the edge is very far away, out in the Oort cloud, a light year or more from home. But if you are measuring the Sun's energy and its solar wind, then the edge is the heliopause, the boundary where the Sun's bubble meets interstellar space. This is the energetic edge of our solar system. Beyond it, you are no longer protected by the Sun's shield. You are in the quiet and much more radioactive space between the stars. It is a subtle and invisible frontier. A change in the cosmic weather, more than a change in location. Even a planet with a thick atmosphere, like Earth, is not perfectly sealed. Atmospheres slowly leak into space. Very light gas molecules, like hydrogen and helium, can sometimes gain enough speed to escape a planet's gravity. This is called atmospheric escape. It happens more on smaller planets with weaker gravity, like Mars. It is one of the reasons Mars lost most of its ancient atmosphere. Even on Earth, we are losing a tiny amount of our atmosphere all the time. It is a very slow and quiet process, a constant, gentle leak into the great vacuum of space. We know that moons can be destroyed to form planetary rings. But the opposite can also happen. Rings can come together to form moons. It is possible that some of Saturn's small, inner moons were actually born from its rings. If enough ring material clumps together beyond a certain distance from the planet, its own gravity can pull it together, into a small, icy moonlet. Some of the tiny moons that orbit within Saturn's rings may still be growing today, sweeping up ring particles as they go. These little moons are both the children of the rings and the sculptors of them. Their quiet gravity, carving gaps and waves in the same material that they were born from. The Voyager 1 spacecraft is now billions and billions of miles away from home. More than 45 years after it was launched. It is still working. Its instruments are still measuring the conditions in interstellar space. And it is still sending those faint signals all the way back to Earth. Its power source is very weak now, and to save energy, engineers have been slowly turning off its systems, one by one. But it continues to whisper to us from across the void. Each signal takes more than 20 hours to reach us, even traveling at the speed of light. It is a faint and lonely voice from the very edge of human exploration. Our solar system is part of the Milky Way galaxy, and just as the planets orbit the sun itself orbits the center of the galaxy. It takes a very, very long time, about 230 million years, to complete one galactic orbit. This is sometimes called a cosmic year. The last time our solar system was in this part of the galaxy, dinosaurs were just beginning to appear on Earth. As we make this long journey, we travel through different parts of the galaxy. Sometimes through dense, spiral arms with lots of star formation, and sometimes through quieter, emptier regions. We are not sitting still in space. We are all riding on a vast, slow, cosmic carousel, silently spinning through the great and quiet city of stars. And so, our quiet journey through our solar system comes to a gentle close for tonight. We have drifted from the hot winds of Mercury to the silent, icy plains of Pluto. We have seen diamond rain and hidden oceans and towering volcanoes. If your eyes are feeling heavy now, that is perfectly all right. Let the last thoughts of these distant worlds fade away. Let your breath be slow and easy. There is so much more to see, but for now, it is time to rest. You have traveled very far tonight, and the universe can wait until morning. I hope you sleep well and dream softly. Good night.